Good evening, children.
Good evening, ma'am.
How are you?
How are you, ma'am? Fine, ma'am. Good, ma'am.
Good evening, beta. Good evening.
How are you?
I'm good. Can you hear my voice clearly?
Yes, ma'am.
Okay, but your volumes are low to me. I'm finding everyone's volume low.
Can you hear me?
Yes, yes, that's perfect. Yes, Neha, Harshit, Trilokya.
Happy Dashra, ma'am.
Okay, so children, today we'll start a new chapter, right? So we have revised all those chapters which we had done. Okay. Now moving to the next part of the chapter, the next part of your book. That is, we are starting with a new chapter, Algebra. Okay. Hello.
Yes, ma'am.
So we are starting with Algebra. Okay. Let's see the screen. Please turn on your videos, everyone. Trilokya, turn on your video, beta. Yes.
Ma'am, my video is on.
Okay, this is Algebra now. Now see, in Algebra, does anyone have any idea about algebra? What is algebra?
Yes,
What?
ma'am.
Yes, Harsha, tell me.
Ma'am, algebra is like alphabetical expressions of numbers.
Yes. How is it different from geometry or arithmetic?
Ma'am, we can multiply those like 2 into B.
2
2B.
into b. 2b. So
2B.
what does
It
this
is
2b says? What is this?
it, it means that 2 into B.
2 into b. What is b?
It's a number.
It's a number. Yes. Okay. So those numbers which can be expressed using alphabets. Okay, we call them as variables. Now first see, now suppose in your chapter you have a matchstick pattern. Now suppose this is one matchstick. You know what is a matchstick, no? Everyone knows. Now suppose with matchsticks, if I have to make this shape. So how many matchsticks are required in making this?
3.
Matchsticks. 2. This is 1.
2.
This is 2. Okay, so 2 matchsticks are required. Okay, if I have 2 shapes like this, then how many matchsticks are required in making these?
4. 4.
So 2 for each, that is 4. So how will I get this 4? 2 matchsticks are required in making this one shape. Okay, and another is this. So 2 into 2 here, right? Okay, suppose if I have this 3 shapes like this, these are 3 matchsticks. Then how many matchsticks are required in this?
6.
So 2 for one shape and I have 3 figures like this. So 2 into 3. And say simultaneously, if I keep on increasing the figures like this, I get 2 into 4, then 2 into 5 and so on. Is it?
Yes,
So for
ma'am.
one shape, I needed 2 matchsticks. For another shape, I needed 4. Then I got 6, then 8 and so on. Are you understanding? So how was this represented actually? How did I get this 4? This is 2 into 1. This is 2 into 2. This is 2 into 3. This was 2 into 4. So every time this number is changing. Yes? Every time this number is changing.
Yes,
This
ma'am.
2 is constant. But this number is changing. So what I will do, I will keep this number as, I'll keep the name of this number as some variable. Suppose if I keep it x. So x can be anything. X can be 1, x can be 2, x can be 3, x can be 5, 10, 100. X can be anything. Okay. If I have to make 100 shapes like this, then how many matchsticks are required? 200. If I have to make 520 matchsticks like this, 20 shapes like this, I will just multiply it with 2. Okay. Right? Are you understanding? So variable means which varies, number that varies. Are you understanding? The number which is fixed, the number which is fixed is called constant. Okay? The number which varies, varies means changes, is called variable. Are you understanding?
Yes, ma'am.
Everyone understood this example?
Yes,
We'll take more examples. We have more examples in your book. Okay. So number which is fixed is called constant. Okay. And the number which varies is called variable. So here I have a variable. Now in this, see here, this number is a constant number. But when I'm multiplying this with some variable, then this number is also changing, no? This number is also changing, no? Are you understanding? When I'm multiplying these two numbers, my result is also changing. No, initially it was 2, then it became 4, then it became 6, it's 8 now. So this is also changing. The result is also changing. Okay. Now suppose, okay, we'll do more examples, then you'll understand. You understood this now? Fixed means constant. Varies is variable. The number that varies is called a variable. Okay. Now see this shape of matchstick. Okay. Now to make this shape, how many matchsticks are required? How many matchsticks are required here?
3. 3. 3. Ma'am, 3.
Everyone can see, no?
Yes, ma'am.
Yes, Adya is here.
Yes.
Adya, how many matchsticks are required in making this shape?
Ma'am, 3.
3. You can see, no? 1 matchstick, 2 and 3. So 3 matchsticks to make this one shape. And if you have to make 2 shapes like this, then how many matchsticks will be required? 3 matchsticks for one shape and 3 more for another one. So 3 into 2.
6, ma'am.
Yes, 6. So if you have to make 3 shapes like this, so that will be
9.
3 into 3. That's 9. And simultaneously now 3 into 4. That's 12. And it goes on. 3, 6, 9, 12, 15, and so on. Right? So this is what, these are all multiples of 3 only. So the variable here is 1, 2. These are the variables, the numbers which are varying, which are changing. Varying means changing. The numbers which are changing are variables. The numbers which are fixed are constants. Okay. Okay, now we have different alphabetical shapes also. So to make a shape of alphabet A, suppose, how many sticks are required in this? 1 second, I'll show you. You have it in your exercise here. Now see. Find the rule which gives the number of matchsticks required to make the following matchstick pattern. Use the variable to write the rule. Now, how many matchsticks are required to make this shape T?
2. 2.
This is one matchstick, this is
2.
one. So this will be 2
2, ma'am.
matchsticks are required. Okay. Okay, so that will be 2 into, and this is for just one shape. If I have 2 such, then
4.
and then 3 such like this. So that
Yes,
can be written as 2n.
2.
I can write it as 2 x. Let's take it x. Okay, let the variable be x. Why x? Because 2 into this is one shape. These are 2 shapes, so 2 into 2. These are 3, so 2 into 3. There are more than 2 into x. Okay? Are you understanding now what is x?
Yes, ma'am.
That's a variable because x can take any value. X can be 1 also, x can be 2 also, x can be 3, and so on. X can be 10, 50.
Whereas variable means unknown.
Variable means unknown. Okay,
Okay, ma'am.
which is not known to us. Okay, and which varies, unknown and varies.
Okay, ma'am.
Okay, which varies, which changes. Okay, which is not fixed. Now, a pattern of letter Z. Now, this is Z shape. How many matchsticks are required in this? I'll ask now.
3.
Wait, I'll ask now. Okay, Trilokya, you tell me.
Ma'am, 3, ma'am.
3. So, what will be my rule here? If there are 2 shapes like this, 3 shapes, 5 shapes, then what should be the rule here?
Ma'am, 3x, ma'am.
It can be 3x for the number of shapes. Okay, x can be number of shape, no? Number of shape means it can be 1, it can be 2, it can be 3. Okay, next, Adya.
Yes.
Adya, you tell me the pattern of letter U as how many matchsticks are required in this?
Ma'am, 3.
3.
Means 3x.
And what will be the rule here?
Ma'am, 3x.
3x. Okay, here x is the variable. X is the variable here. Are you understanding? Okay.
Ma'am, is x the variable of number of views here?
X is the variable, yes.
Ma'am, the variable contains, the x variable contains number of views in it.
Yes, x variable means how many u's are there? This is 1. Then in the next figure you might have 2. Then you might have 3. Okay, and it continues. If you have suppose multiple u's here, so many u's are there. So how many matchsticks will be required here? So you will count these u's, no? Okay.
Yes, ma'am.
So in that case, we are writing this variable. So x can take any value. It can be 1 here, it can be 2, it can be 3, like this, it can be 2, it can be 3, it can be 6, and it can take any value. All right? Now see,
Okay,
the
ma'am.
pattern of letter V. Neha, tell me.
Ma'am, number of matchsticks in V is 2.
2, and what will be the rule?
Ma'am, the x variable.
Yes, x variable, so 2 multiplied by x, which is 2x.
Yes, ma'am.
Okay, now tell me, Neha, how many matchsticks are required in E, making this shape E?
5.
Okay, so you can see the shape, everyone, like this. This is 1 actually. This is another one, and this is here. 1, 2, 3, 4, 5. So these are 5. And what will be the rule?
Ma'am, a number of matchsticks into number of
Shape.
number of E's.
Okay, number of shapes. So that will be 5x. Okay. Bhavesh, tell me this. S.
Ma'am,
S is
number of
like this, like this,
matchsticks.
like this, like this, like this, like this.
Number of matchsticks 5.
Okay,
Means 5x.
very good. Matchsticks are 5, so 5 into x will be 5x.
Same
Good.
as E.
Yes. Okay, Harshit, now tell me this shape.
Ma'am, 6x.
Yes, this will be
It's a
6. It's
6.
like this. Okay, like
Ma'am,
this.
6x.
Yes, so this is 6 multiplied by x. Right? Everyone understood this? The basic rule here?
Yes, ma'am.
Okay. Now, children, you can note down in your notebook. Please note down in your notebook. Let me pick a page. 1 second. is algebra. Okay, you can note down now. See, now you see when we were writing mensuration, when we were doing finding the area of a rectangle, perimeter. So what we were doing there, area of a rectangle, we were representing as L into B. So this was what? L was the length, B is the breadth. Now, when you were finding area of square, what were we doing there? That was side into side. So side was not known to us. So we were just writing side into side like this. A into A was A square. Yes. So this is also writing in terms of variables. We're writing in terms of variables. Are you getting? When we were writing the area of a perimeter formula for a rectangle or a square, we were writing 2 into L plus B. So here L plus B were variables. Okay. Are you understanding? When we were writing the perimeter of square. So that was what? 4 into side. So 4 into A. So A was a variable. Okay. Are you understanding? Because in a square, we know there are 4 sides. So 4 into A like this. Okay. Right? This is what we were doing. Same like what you did just now for the matchstick pattern. Okay. So unknowingly, you were already using algebra. Okay.
Yes, ma'am. We even used it in the formula of number of diagonals.
In the number of
Diagonals.
diagonals, absolutely. To form number of diagonals, n into n minus 3
By 2.
okay, to find the number of diagonals. When you know the, suppose this is a quadrilateral, a polygon. How many sides are there? 4 sides. So n is the number of sides. So 4
Yes.
into 4 minus 3 by 2, which is equal to 4 into 1 by 2, which is equal to 2. So diagonals will be 2 diagonals. Okay. You were doing this, no? Diagonals are what? From one corner to another, like this. So it would make 2 diagonals. Okay? Yes, children?
Yes, ma'am.
So you have, unknowingly, you were already using all these things. Okay? Okay. Now please write down for algebra the letters okay. So just remember here. Let's write these points are to just to remember the letters used to represent the letters used to represent the numbers are variables. The letters used to represent the numbers are variables and combination. Please write down nicely, neatly in your notebook. And combination of letters and numbers. So you can see when you were writing 2x, so this is a combination of a letter and a number. Okay? Combination of letter and numbers are algebraic expressions. Okay, these are called algebraic expressions. We call these as algebraic expressions. So 2x is an algebraic expression. Okay, so 2 into L plus B is an algebraic expression. 4a is an algebraic expression. Okay, so for example, we can write this as suppose you were finding out 5x. This is an algebraic expression. Suppose if you have something like, x plus 7. So that is again an algebraic expression, type of algebraic expression. Okay, like this. x square plus 3. This is again an algebraic expression. So somehow you have algebraic expressions like this. That is a combination of a variable and a letter. A combination of a letter and a constant number. Okay. A letter and a number. Right? You understood? Hello, did you all understand this part?
Yes,
ma'am.
Anyone has any difficulty? Okay. And moreover, see children, when I am writing these examples, you can see these operations here. Plus is there, minus is there, multiply is there. Is it? You can see these operations also, right? And you can see some power also, x square. And suppose if you are finding area of a square, this is again a square. Are you getting? A square means what? A into A. So you can see some powers, see some operations, plus, minus, the algebraic expressions. Okay, please write down this next part. An algebraic expression.
Ma'am, we need to write the side part also.
Yes, beta.
Side all writings. Side. The side of the remember one.
Side of the, say loudly.
Remember one, ma'am. Remember one. Those A are
Remember.
equal L into B. Those.
L into B. Huh, this is also. These are also variable forms.
I need to write that.
No need to write that. This is just to explain you that I was explaining that you have already been using all these things, but unknowingly, you did not know that these are all algebraic expressions. Okay?
Okay, ma'am.
No, you don't have to write this. This was only to explain you. Okay, an algebraic expression is made up of variables and constants along with operations. See what are operations? The addition, subtraction, these are all operations. Okay. Operations means mathematical operations. Addition, subtraction, etc. Multiply, divide, these are all operations. Along with operations, expressions are made up of terms. Expressions are made up of terms. Now, for example, now see this, the example which I gave you here, x square, okay, x plus 7. The example which I gave you, see here. Everyone please pay attention. Now see, there are two terms. This is 1 into x is x only and this is 7. But how can I say that these are two terms? Because they are separated by this plus sign. Yes, this is one term plus another term. Are you understanding? Okay. Similarly, here I have x square plus 3. X square is one term, 3 is another term. There is a plus sign in between the two terms. So the two terms are being added here. Similarly, I can take another example of like this with three terms, x square minus 5x plus 9. Yes, so now in this example, I have these three terms. Okay, all right. So terms are always separated by addition and subtraction. Okay, but when it is a multiply sign in between, like suppose 5 into x is 5x. This is not this multiply is not separating the terms. 5x itself is one term. Okay, only addition and subtraction separate the terms. Okay, this is one term, this is another, this is another. Here also you have x square. So x square is x into x only, but we are considering it as one term. So term separation is only when you have plus or minus sign in between. Okay? Yes?
Yes, ma'am.
Hello,
Yes.
say something.
Yes, ma'am.
Everyone understood this?
Yes, ma'am.
So terms are specified only when you have plus and minus sign. But suppose if you have some term like this x square 5 into x, so then multiply will not separate the term. Okay? Only plus and minus will separate the term. So this algebraic expression has three terms. This one, and this one. This algebraic expression has two terms, this and this. This algebraic expression has two terms, this and this. And suppose if I have algebraic expression like this, so this has one term, okay? This has one term. This is only x, okay? You will not say that these are two terms because there is no plus or minus sign in between these two, okay? Understood?
Okay, ma'am. Yes.
Okay. Okay, let's do more questions on this so that you will understand it much better. One second, I'm coming to the chapter. Okay, let's see now. Question number 2. Make it little big. Okay. We already know the rule of for the pattern of letters L, C, and F. Some of the letters from question 1 give us the same rule as that given by L. Which are these? Why does this happen? Okay, why does this happen? Why does this happen? Very simple rule. So to make T, we need two matchsticks. To make V, we need two matchsticks. Okay. Yes. And which other combination is there where we need two letters? So that's TV. The letter L requires only two matchsticks, right? Yes, children?
Yes,
Are you understanding?
Yes,
The letter L requires only two matchsticks. Therefore, the given pattern for L is 2x. T and B also has the same pattern, which requires two matchsticks. 2x, 2x, like this. Okay? Right?
Yes, ma'am.
So this is just a simple question. Why does this happen? Means just two matchsticks are required in this. So the formula will be, the rule will be the same. Okay? Just a simple thing. Okay, now see, cadets are marching in a parade. Have you all seen a parade? How people walk in a parade, the cadets walk in a parade, they walk in
Like
lines,
soldiers.
like this.
Like
This
soldiers.
side also they are walking regularly, this side also they are forming a line. Okay. A regular line, both vertically also, horizontally also. Cadets are marching in a parade. There are 5 cadets in a row. Now they are saying there are 5 cadets in one row. Row means horizontal. Okay, let's make it 5. There are 5 cadets in a row. What is the rule which gives the number of cadets given the number of rows n? Okay, if they are saying the number of rows are n, so how many cadets will be there in total? 5 cadets in one row. Rows are n. Okay, rows are n. This is one row, this is second row, third row, fourth row, and so many n rows. So what will be
N
the
to the
rule?
power of
Which
5.
rule will follow here?
Mama, 5 power 4x.
Rows are n, cadets are 5. So what will be the rule? Total cadets will be how many?
Ma'am, N to
5
the power of 5.
5. 5n. Very good.
Oh,
Okay. Are you understanding?
Yes,
So
ma'am.
total
Yes.
cadets will be 5n. Okay. Now, let's see this question. If there are 50 mangoes in a box, okay, how will you write the total number of mangoes in terms of the number of boxes? Use B for the number of boxes. Okay, for number of boxes.
Can I say? Ma'am, can I say?
Yes.
50B.
Ma'am, 50B.
So in one box there are
B.
50 mangoes and there are in total B boxes. So total rule will be, total mangoes will be 50B. Okay.
Yes, ma'am.
Okay, I hope you are understanding now. I'm going to make it little enlarge it. 1 second, let me make it little big. Yes, now it's okay. Okay, let's see question number 5. The teacher distributes 5 pencils per student. Per means 1. Okay, 5 pencils per student. Can you tell how many pencils are needed given the number of students? Okay, now the number of students are
5S.
given S.
Ma'am, 5S.
5.
5S.
Yes, 5 into S will be 5S. So 5 pencils are given to every student. So how many students are there? There are S number of students. Okay. Okay, now let's see. A bird flies 1 kilometer in 1 minute. Can you express the distance covered by the bird in terms of its flying time in minutes? Use T for flying time in minutes. Now, T is the flying
T.
time. Okay,
T.
it flies 1 kilometer in 1 minute. 1 kilometer in 1 minute. So 1 kilometer in 1 minute. So time is T. So that is 1 into T kilometers. Okay. Yes.
Ma'am, isn't it 1T?
Yes, it's 1 T only, no? 1 into T only.
Okay.
Okay.
Yes, ma'am.
Everybody understood this?
Yes, ma'am.
Yes,
Yes,
Trilokya, you understanding? See, it's saying the bird flies 1 kilometer in 1 minute. So how many minutes are there? Minutes flying time is T. Okay. So that means in 1 kilometer into time T. So 1 T. Okay. Okay, let's see the next question, number 7. Radha is drawing a dot rangoli, a beautiful pattern of lines joining dots. With chalk powder, she has 9 dots in a row. Okay, she has 9 dots. So many 9 dots in one row. How many dots will her rangoli have for our rows? For our number of rows, in every row she has 9 dots. So how many dots will her rangoli have for our rows? How many dots are there if there are 8 rows and if there are 10 rows? So for 9 rows, how many dots will she have?
81.
First tell me for 9 rows, how many dots for our number of rows, how many dots she will have? In one row, she's having 9 dots. So in R rows, she has 9 R dots, no?
Yes, ma'am. 9R.
9 into R. Okay, now if she has 8 rows, then uh, uh, how many dots will she have?
Ma'am,
If R
8
is
into R.
yes,
8 into
8
9.
R. Ma'am, 8 R.
yes, not 8 R. It's if she has R rows, 8 rows. So 8 rows means R is equal to 8 here. So
Yes.
8 rows she will have 8 into 9.
Yes.
72 dots. Okay. Are you
Okay,
understanding?
ma'am.
Similarly, if she has 10 rows, here R is 10. So 10 into 9 will be 90
90
dots.
dots.
Are you understanding, children?
Yes, ma'am.
Everyone is understanding.
Yes, ma'am.
Is there any child who is not understanding? Okay, now I'll ask you. Oh, the time has gone up. Okay, so I'll ask you in tomorrow next class. Okay, in next class you will be doing these questions. Now I've explained you so many questions, no?
Yes,
Next class you will be doing these questions. Okay, you will tell me. Okay,
okay, ma'am.
thank you for today. Please revise this, whatever we have done and whatever we have written. Okay, thank you so
Okay,
much, children. Bye
Thank
bye.
you, ma'am.
Thanks
Have a
for
nice day.
joining.
Thank you, ma'am. Have a nice day.
Okay, thank you. You too.
Bye, ma'am. Have a nice day.